All right, so this is an alternative method for finding the derivative at a specific point, okay? Typically, we would use this formula. We would say, hey, let's do the limit as delta x goes to 0 for f of x plus delta x minus f of x over delta x. And then we would use our f of x here, being x squared plus 4, to use within this, this limit problem. And in the end, once we got our expression, okay, for f prime of x, I would input 3 and work it out, okay? Now, here's an alternative way. And what I'm going to do is this. I'm going to start off with this x equals 3 and replace all my plain x's, okay, just the x's with 3's, okay? The delta x's will stay as is. Okay, so I have the limit as delta x goes to 0. And that would seem to make sense, right? Just because that's what x is. X is 3. Let's replace these with 3's. All right, so what does that mean for us? Well, what it means is I'm going to take this 3 plus delta x and input it into my f of x. Okay, and then I'm just going to work it out like I would any other math problem, like we've been practicing. And let's see, this means multiply. So let's see, 3 plus delta x, 3 plus delta x plus 4, minus an f of 3. Let's see, f of 3, if I did this up here, is 3 squared plus 4, which is 9 plus 4, which is 13. All over delta x. Now, some of you will look at this and say, well, wasn't the back piece supposed to cancel with items in the front? And the answer is yes, but let's simplify a little bit more. All right, what does that mean? Well, I'm going to take this item here and I'm going to multiply it. So that's 9 plus 6 delta x plus delta x in parentheses squared minus 13. Sorry, plus 4. Forget that plus 4. Minus 13 all over delta x. All right, so that is my limit as delta x goes to 0. And let's see what we're left with in our numerator. Well, here's our subtract 13. If I have this 9 and this plus 4 from right here that I just snuck in, 9 plus 4 is 13, minus 13 go away. So I'm left with a 6 delta x plus a delta x squared. And I shared earlier that this delta x has the potential of canceling out with items in the top, provided that we factor well. And here's my delta x. And on the top, I have a delta x as well. And that's 6 plus delta x. And these will go away. And so I'm almost done. I have the limit as delta x goes to 0 of 6 plus delta x. And again, as this item goes to 0, I'm left with 6 plus 0, or 6. That went fast. Okay, and so what does that mean? Well, had I done this the traditional way, right, and worked it out and got some expression that I would set equal to f prime of x, and then inputted 3 into that answer that included an x, you should have finished with a 6. Okay, and again, this is just another way of doing it. It helps save some time in terms of plugging in a value at the ends. The disadvantage of this is that if I wanted now x equals 2, I don't have the generic formula with the generic f prime of x that I could substitute 2 in for. I'd have to actually do this thing all over again. So it's kind of up to you to decide whether this is of value, in my opinion. All right, now this feels like a bigger problem because it says find the equation of not just the slope of the tangent line, but they want the entire tangent line, okay, to the graph of g at the given point. You're like, man, that feels like a lot. So, but it actually goes pretty quick. It's not too much different. And you have to choose either the old way or the new way for finding the slope of the tangent line first at x equals 4, okay? This y is equal to 8 will come to play because in the end, I have to find the whole equation of the tangent line, but we'll wait on that, okay? Just for the sake of practice, let's do this. Let's find g prime of 4 by using our new method, okay? So g prime of 4 is equal to the limits as delta x goes to 0, okay? And we'll kind of do this longhand first just to make sure we got the idea. This is g of, normally we'd say x plus delta x, but my x here is 4 plus delta x, okay? Minus g of x, and again, x is 4, okay? All over delta x. Okay, now what does that mean? Well, I'm going to take this 4 plus delta x and put it into both of these, all right? And if you think that looks bad or uninviting, it may, but it's not really any different than having an x plus delta x in my opinion. So, all right, so here's what I do. I like to put these in first, just so I remember to include the entire function and not just pieces of it. And then remember, this back piece is just g of whatever our x is for. Okay, and then I need to replace my x's here and here with 4 plus delta x. All right, so 4 plus delta x gets inputted in the top, and we are now squaring it. So this becomes 16 plus 8 delta x plus delta x squared. Okay, let us make this a plus -2 and distribute that through. That will give you subtract 8. Okay, and a -2 delta x. Okay, and g of 4, well, g of 4 is, well, 4 squared minus 2 times 4. And I think that gives me 8. Okay, so all over my delta x. I know I did my work at least somewhat right, as long as the subtract 8 cancels out with some of the terms that I have in the front. It should disappear completely with the other constants. And you can see that it does. Okay, I have 16 here. I have a subtract 8, which gives me 8, minus another 8, which gives me 0. So those will go away. And it leaves me with 8 delta x plus, in parentheses, delta x squared, okay, minus 2 delta x. Okay. All right, let me write some work up here. If I've done my work right, there's a chance that my delta x will cancel out on the bottom, and actually it should. This is the limit as delta x goes to 0. And I'm going to factor out a delta x. Okay, pardon me. And if we look at that, it looks like, wow, I have some work. items here that I could combine, and I guess we could have combined these either, the 8 delta x and then minus 2 delta x, but in the end, that'll be okay. Nothing we did was wrong. And these delta x's disappear, and I'm left with a 6 plus delta x, and that leaves me with, well, if you input 0 in for x, sorry, the delta x here, it leaves you with 6. Okay, and what that tells you is what f prime of 4 is. Okay, now how is that helpful? Well, here's what I got. It says find the equation. Now, the equation, I'm going to write in a form that we're not typically used to in mathematics. Okay, this is called point slope. Okay, and then here's what I'm going to do. I have to find values for an x value, a y, and a slope at x equals 4. All right, slope of the tangent line, basically. And what's nice is I have all of these answers provided. Okay, my x1 is going to be the 4. Okay, so I'm just going to write that in. My y1 is going to be the 8. Okay, so 2 of my 3 pieces are already identified. Okay, I didn't really have to do a heck of a lot of computational skills to figure out what those are. The last thing, okay, is they want to know the slope of the tangent line at x equals 4, and you've done that. The 6 goes in this spot. All right, now here's the good news. At this point, we are not expected to go any further. You are allowed to leave your answer in this form, and it's almost encouraged. Okay, on an AP exam, if you work this all out and you finished at this spot and you stopped, you would get full credit. Okay, if by chance you make a silly mistake, either by distributing or adding the 8 over in an odd way, and it makes your answer a little bit off, you will get points marked off for that. All right, so don't simplify, stop, box your answer, and feel good for the first time that you don't have to simplify like we typically do when you have equations of lines. All right, great. All right, here's the deal. In this case, they want you to work backwards. Okay, I'm going to back up 2 slides just so you can see. Okay, this basically was the function that they gave you, and this is basically your C value of 3. What I want to know is, if I set this up for you, can you tell me what the original function is? And can you tell me what the C is, which is basically the x value that you plugged into the x plus delta x, okay? So sometimes it's easy to do this part first because I look for that x plus delta x that was replaced by a number, okay? And you may notice that right here, okay? And so what that means is the C value that got inputted for x is a 1. Okay, and if you can imagine, remember what this is. This is f of, it's kind of like the c or the x that you had, plus your delta x minus f of c equals, over delta x. And again, this is the limit out front. Okay, so you found this guy, which is the c, okay, which is 1. Now, you got to think about, what is the equation? Okay, well, if your equation is determined through this input of c plus delta x, and you see that out here, then that will help you decide what your function is, which is 2 plus 3. And again, the original function didn't have this here. It was just a plain x. Okay, so if you wanted to check it, you could say, yeah, I'm going to take this 1 and plug it into here. And you can see that that represents this first piece, 2 plus 3 times 1 plus delta x, which is what this is. Okay, minus this f of 1. Now, you're like, that doesn't look the same as what I have here. But if you test this and you plug in 1 to this little function piece here, okay, so f of 1, you do get 2 plus 3 times 1, which is 5. Okay, and that's why you have that there. So these are kind of like Jeopardy questions. They give you the answer, you got to find the question, and sometimes it just takes a little bit of thinking to, a little bit of problem solving to work backwards and figure out what those two are. All right, next one says identify the function f that has the given, let me move myself out of the way a little bit. That's fine, characteristics, okay? And you're invited to draw this, and I am going to find a straight edge if I can to make this workable. And I don't have one. I'll have to use my phone. Okay, so here's what I'm gonna do. Let's see. I just need it to make my graph. All right, so here's what I got. I got f of 1 is equal to 2. That's the first item right here. And all that means is I have a point at 1, 2. I'll make that dark. I'm not going to do anything else. Okay. All right, the second thing it says is that f prime of x. Now remember what f prime of x is. That is your slope. Okay. When your slopes are bigger than 0, which means your slopes are positive, that's what slopes bigger than zeros are, when x value is less than 1. So here's 1. It could go through this. It doesn't necessarily mean that have to, but your slopes have to be positive. Okay, so it must go from left to right, even though I'm showing this goes down forever, from left to right as you move this way, okay, that you are increasing, basically. That's what it means when your slopes are positive, until you get to 1. Okay, and then your slopes are less than 0, or basically negative, when your x is greater than 1. So your slopes are less than 1, okay, when your x is greater than 1. Okay. Now, this is just coincidence that we had this part right too. It says f prime of 1 is equal to 0, which means your slope, okay, at x equals 1 must be 0, okay? Okay, it must have a slope of 0. And what that means is it should be horizontal here. And you can see that that does look like it has a horizontal tangent line. Okay, so you are solid on that. Are there other ones that you could do this way? Maybe so, but when they give this criteria at the end, what it means is that you better have this be continuous at the spot, okay? And so that you're able to make a tangent line of 0. All right, where is this function differentiable? Now let me give you some definitions, okay? A function is differentiable, I'm just gonna say this, at a point, okay, as long as a couple things happen. One, okay, it must have a limit there, okay? The limits as x approaches that value, okay? I'm just gonna say c of f of x must exist. Okay, so the limit must exist there. Okay. Second, it must be continuous there. Okay, which means the limit must exist there, and there must be an f of c there, of course. Okay, so which we've talked about. And the last thing is that if it's continuous and the limit exists at c, okay, and then one is a subset of another, that's okay. You have to have a smooth curve. Okay, so not only does it have to be continuous and differentiable, but you have to have a smooth curve there, meaning nothing that looks like this at C. Okay, you can't have this graph where at C you have some like sharp curve or bend or something like that. All right, so where is it differentiable? Well, you can find slopes of tangent lines along all these points, okay, until you get to this spot here where there is an open interval, open circle, at -1. Okay, so where is that? Well, I don't know if this goes on forever, but I will assume maybe it does. So I will say it's differentiable from -infinity to -1. okay? And then I'll consider other options, okay? As you move again in the more positive direction, okay, it is differentiable because it is continuous at each one of these locations, okay? And it's also continuous as you move down to the 2 here. However, at 2, okay, it is not differentiable because you have one of these funky sharp turns, okay? And so at 2, while it is continuous, okay, and when it does exist there, we don't say that it's differentiable at 2, okay? There is no slope here. You can make a slope this way, you can make a slope that way. There's just a lot of slopes that you can make. That's why it's not differentiable there. And then finally, anything after 2 is legit. Okay, it's differentiable, and again, we'll assume that goes on forever, at least for what we can see. Okay, and once I've identified all those places where it is differentiable, I will put some union signs there. Okay. Now, I know some people will look at this and say, hey, that's just part of this rule. It is, okay? And you don't necessarily have to write this first part, but sometimes I like to think with the most fundamental sense as I work through a more specific list of criteria for something that is, in this case, differentiable. All right, that is it. Okay, this is the homework assignment from page 123 in your Larson book. If you have any questions, then holler at me and we can talk further. Have a good night.